Ever spent days chasing a bug that only shows up on Tuesday at 3:17 p.m. when Mercury is in retrograde and only for that one user? Yeah, you know the type. These phantom bugs aren't just annoying. They cripple productivity, erode user trust, and can cost companies millions in lost revenue and developer time. Your sanity is on the line. By the end of this video, you'll have a battle-tested strategy and a mental toolkit to track down and squash even the most elusive, non-reproducible bugs. The Phantom Menace. What makes bugs elusive? Okay, so you get a bug report. It just broke. I refreshed and it was gone. Sound familiar? These aren't your typical syntax errors. They're the shadows lurking in your codebase. What makes them so random? Often, it's a perfect storm of factors. Race conditions where operations finish in an unexpected order, subtle environment differences, or external API flakiness. Hot take. If your system isn't deterministic, you're just asking for these kinds of headaches. I genuinely think the biggest mistake devs make is assuming it works on my machine means anything when a customer is reporting issues. You're not the customer. Their environment is the truth. So how do we even begin to catch these ghosts? Beyond console.log, the debugger's advanced toolkit. Real talk. Console.log is great for quick sanity checks, but for phantom bugs, it's like using a flashlight in a blackout. We need structured logging, proper tracing, and sometimes even remote debugging capabilities. This is where you level up. Tools like Jaeger or OpenTelemetry let you trace requests across multiple services, giving you an end-to-end view of what happened. This is gold when a bug jumps between your front-end, back-end, and a third-party API. Honestly, if you're building microservices without tracing, you're playing on hard mode. Sometimes, you need to be in an environment where the bug lives. Remote debugging lets you attach your debugger to a running process on a staging or even production server, albeit with extreme caution. It's a powerful weapon, but wield it responsibly. Wild, right? Environment parity, the holy grail of reproducibility. It works on my machine, problem often boils down to environment drift. Your local setup, staging, and production environments are rarely identical. Docker and virtual machines are your best friends here, ensuring consistency from development to deployment. Using Docker containers or even cloud-based dev environments like GitHub Codespaces can guarantee that everyone, including your CI/CD pipeline, is running on the exact same stack. Some devs swear by perfect parity, others say it's an impossible dream. I lean towards striving for it. The closer you get, the fewer phantom bugs you'll encounter. Beyond the runtime, configuration management is crucial. Environment variables, feature flags, database seeds. These all need to be consistent across environments. A quick side note, don't hardcode secrets, please. Use a proper secret management system. Your future self will thank you. The time travelers, observability and monitoring. When a bug can't be reproduced on demand, your best bet is to become a time traveler. We're talking about robust observability, APM tools, detailed metrics, and alerts. You need to know what your system was doing before it broke, not just that it broke. All right, we've talked about catching these elusive bugs, but here's the twist. What if you could force them to appear, or better yet, prevent them entirely? That's what we're diving into next. Distributed tracing, which we touched on earlier, is a cornerstone of observability. It gives you the full story of a request as it hops between services. Combine that with custom metrics, not just CPU and memory, but business-level metrics specific to your application, and you start painting a complete picture. Still with me? Alerts are your early warning system. Don't just alert on server is down. Alert on anomalies, sudden spikes in error rates, unusual latency, or a drop in successful transactions. It frustrates me to no end when teams only react to outright failures instead of proactively catching subtle degradation. That's the gist. Reproducing the unreproducible, strategies for forcing the issue. Sometimes you have to play offense. If a bug is truly random, you need to create conditions where it's more likely to appear. This means stress testing, fuzz testing, and sometimes even a little controlled chaos engineering. Stress testing involves bombarding your system with high loads to expose race conditions or resource leaks. Fuzz testing throws unexpected, malformed, or random inputs at your code. It's like giving your application a really bad day on purpose. Makes sense? And then there's chaos engineering, popularized by Netflix, intentionally breaking things in production to test resilience. I know this part is dense, but stick with me. If you can't reliably reproduce a bug, sometimes the answer is to create a controlled environment where its conditions are met or even forced. It's not for the faint of heart, but it's incredibly effective. The human element, communication and documentation. Even with all the tech, debugging often comes down to people. Getting good bug reports from users is paramount. It broke isn't helpful. You need steps to reproduce, environment details, screenshots, and even video recordings. Honestly, a well-written bug report is half the battle won. Document your debugging journey. Seriously, what did you try? What did you find? Where are the dead ends? This isn't just for your future self. It's for your team. You might spend days on a bug, only for a colleague to hit the same wall months later. Don't let that happen. It's a quick side note, but a crucial one. And finally, learn to say, I don't know, but follow it up with, but I'm going to find out. Debugging isn't about being perfect. It's about being persistent and methodical. It's a humbling process, but every solved phantom bug makes you a better developer. Now you know. Prevention is key. Building resilient systems. The ultimate goal isn't just to debug these random issues, but to prevent them. This means building resilient systems from the ground up. Think about idempotency for operations, robust error handling, and implementing retries with circuit breakers. Defensive programming means anticipating failures and handling them gracefully. Validate inputs, check for nulls, handle edge cases. It's not about writing more code, it's about writing smarter, more robust code. Unpopular opinion, a lot of random bugs are just unhandled edge cases. Finally, embrace a culture of learning from every bug. Every time a phantom bug rears its ugly head, it's an opportunity to strengthen your system and your processes. It's a continuous journey, but one that makes you a formidable force against the unknown. Go build something resilient. Let's recap. Random bugs are often due to race conditions, environment drift, or external factors, making them incredibly hard to reproduce. Advanced debugging tools like structured logging, distributed tracing, and remote debugging are crucial for visibility. Environment parity through containers and robust configuration management minimizes "it works on my machine" scenarios. Observability with APM, custom metrics, and anomaly alerts lets you travel back in time to understand failures. Aggressive strategies like stress testing, fuzz testing, and chaos engineering can force elusive bugs into the open. Effective communication, detailed bug reports, and diligent documentation are vital human factors in the debugging process. Proactive measures like idempotency, circuit breakers, and defensive programming build more resilient systems, preventing bugs before they even start. The key takeaways: invest in a robust observability stack early. It's cheaper than endless debugging. Strive for environment parity across dev, staging, and production using tools like Docker. Don't be afraid to break things in a controlled way to expose weaknesses in your system. Prioritize clear communication and documentation for bug reports and debugging efforts. Shift from reactive bug fixing to proactive bug prevention through resilient system design. If this helped you understand something new about tackling those infuriating phantom bugs, consider supporting the channel. Every bit helps keep these videos free for everyone. Drop a comment with your thoughts on your worst, unreproducible bug story.